Hello everyone, we're going to be looking at a question regarding electric circuits. Alright, now in this electric circuit we are not going to have in consideration the internal resistance of the battery as well as the resistance of the conducting wires. Okay, this question said 3 resistors are connected to a battery as shown in the circuit diagram below. Right, the potential difference across a resistor R1 is 10 volt and the current I1 through the ammeter 1 is 0.4 amperes. The resistance of resistor R2 and R3 are 3 ohm. So let's write down here, write on the circuit all the data we have. We know that the potential difference across R1, I'm going to call it V1, is going to be equal to 10 volts. Right? The current I1 through the ammeter 1, I1 is going to be equal to 0.4 amperes. We have that the EMF of the battery is 10.6 volts, and we have that R2 is equal to 3 ohm as well as R3. This is 3 ohm. Okay, let's pick the ohm here. This is 3 ohm. Okay, now before we go on, let me explain something because a learner asked me about this situation. Ammeters can only be connected in series. Why is that so? Ammeters have very low resistance. So let's say you connect an ammeter in parallel to a resistor. What is going to happen is that the current is going to flow through the part that have less resistance. So all the current will go through the ammeter. No current will flow through the resistor. Okay, that is why ammeters must always be connected in series. And the opposite with voltmeters. Voltmeters have very high resistance and therefore must be connected in parallel. If you connect the voltmeter in series to a resistor, the current is not going to flow because the voltmeter have very high resistance. So we cannot connect voltmeters in series or ammeters in. Okay, so let's go to answer the question. The first question says define potential difference in watt. Right? So solution 1.1 potential difference. What is potential difference? Potential difference is going to be energy transfer per coulomb of charge, or work done per unit charge. Work done per unit charge. Let's record quickly the formula for a potential difference. Potential difference symbol is V and is equal to W, which is work done or energy divided by charge, and that is the meaning of work done per unit charge. If you answer this question correct, then you get the 2 marks. Right, let's go to 1.2. 1.2. Now question 1.2 says what is the potential difference across the resistors R2 and R3. Now let's note the following. R2 and R3 are connected in parallel. Alright, so all this on here, all this connection here, we are going to call it, all this one here, we're going to call it resistance in parallel. Alright, now what you need to know here, the EMF is equal to the potential difference across resistor 1 plus the potential difference in parallel. We go here, the total one here must be equal to this one, which is 10, plus this one, which is the resistance in parallel. If you substitute here, you have that 10.6 is equal to 10 plus potential difference in parallel. Right? So potential difference in parallel is equal to 10,6 minus 10. The potential difference in parallel is equal to 0,6 volts, right? So that is the potential difference in parallel. Now remember from previous videos that the potential difference across each resistor in parallel is going to be the same. So we can say that the potential difference 2 is equal to potential difference 3 and is equal to potential difference in parallel, which is 0,6 volt. This is the answer for this equation. If you want to give mark, the marks allocation should be 1 here for this substitution, 1 for the final answer. So every resistor, the potential difference across each resistor is 0,6, and there is the same because the resistors are connected in parallel. Okay, now let's see what is the reading of the ammeters A2 and A3. So first we can look at A3. The meter on A3 is the same. Remember from previous video that the current across a circuit is going to be the same everywhere except for the parallel connection. Here the current will be split in two parts. However, here it's coming together again and it's going to be 0,4 amperes, the same as the first ammeter. So that is for 1.3.2 is equal to I3 is equal to 0,4 amperes. This is the same one as the beginning. Now 1.3.1. There are two options to do this question. Option 1, option 2. So let's look at option 1. Option 1, we can use Ohm's law, which was done already. Ohm's law, remember in Ohm's law, the formula to calculate resistance, the formula to calculate current, we have that current is equal to potential difference divided by resistance. We are working for resistor 2. This is for R2. Alright, so we're working with current 2, potential difference 2, resistor 2. Okay, so this one is going to be equal to 3 ohms divided by the potential difference was calculated already. This is 3 potential difference is it's going to be 0,6 divided by resistance, which is 3. 0,6 divided by 3 is equal to 0,2 amperes. This is the first option. The second option, you know that R2 is equal to R3. Okay, and then because they are equal, the current is going to be split equally. Okay, so we can say that I2, which is equal to I3, current 2 must be equal to current 3 and must be equal to current 1 divided by 2. The current that passes through this resistor 2 and resistor 3, they are the same because they have the same resistance, and it is divided from here, from the beginning. So this one will go half there and the other half there. So the current for any of these two resistors is equal to the total current divided by 2. So this is going to be equal to the total current is 0,4 divided by 2. Therefore current 2 is equal to 0,2 amperes. This is the other option, or the other way to solve that question. If you look for the marks allocation, here is one for this one for that one, and here is one for dividing by 2 and one for them. This is 2 marks for this equation, and then this one, which we answered already, is only 1 mark, and there is the answer for 1.3.2. Finally, it's 1.5. Sorry, question 1.4. Question 1.4. Now, question 1.4 said calculate the energy consumed through R1 in 5 minutes. Here's R1, okay? So, let's write here the time is 5 minutes, you cannot work in minutes. You have to multiply 5 times 60 because 1 minute have 60 seconds. This is equal to 300 seconds. You work with seconds. Okay. Now they're asking for energy transfer. We go into the definition of potential energy, potential difference. Potential difference equal to energy transfer per unit charge. If you rearrange this formula, you have that energy transfer of W is equal to potential difference multiplied by charge. However, we do not have the charge. Now, where do we look for the charge? The current is equal to the charge per unit time. It's the rate of flow of charge. If you rearrange this formula, you have the charge is equal to current multiplied by time. So we can calculate this charge here, current that passes through the R1. The current that flows through R1 is 0.4. 0.4, and the time is 300. Right? So we can now quickly calculate 0.4 times 300. This is 120. So this is 120 coulombs. And this charge is going to be substituted there. So now we can calculate the potential, the work done, the energy. Energy is equal to potential difference, which is 10, multiplied by the charge, which is 120. So the energy transfer is going to be equal to 1,200 joules. This is the answer. You get 6 marks for this one. 6 marks for that one. Let's make sure. Yes, 6 marks. So 1 mark will be for this formula. 1 mark for this formula. 2, 3, 4, 5, and 6. They are all the marks allocation. Okay, and then we go to the last question. The last question, which is a 1.5. Now in 1.5, they ask you to calculate the equivalent resistance in parallel. All right. So there are 2 options to do it. 2 options to do it. The first one, resistance in parallel, is equal to 1 divided by R2 plus 1 divided by R3, everything to the minus 1. You substitute, is 1 over 3 plus 1 over 3 to the minus 1. Resistance in parallel is equal to 1,5 ohm. Alright, now option 2, we can use the other formula because we have only 2 resistors. The product of R2, R3 divided by the addition of R2 plus R3. So if you substitute, you have 3 times 3 divided by 3 plus 3. And this, the parallel resistor, equivalent resistance in parallel, is 1,5 ohm. This is the other option, so you can either use one of them. The mark allocation is 1 for the formula, either one that you use, remember it's O. Okay, 1 for each substitution, 1 for the final answer. There is 4 marks. So this is the question. The total for this specific question is 17 marks. Okay, thank you very much. I'll be checking other questions, other examples. I hope you understand. You can ask a comment, you can ask a question if you don't understand something, and I'll be pleased to answer you and help you. Okay, thanks a lot.